Today's topic will be learning how to use combined derivative rules in order to differentiate various functions. This is a topic from Calculus 1. My name is Kurt Overhiser, and I will be your guide as we look through a couple of examples of how to take derivatives of more than one derivative rules at a time. The first example that we're going to look at will be the function y equals x cubed times the tangent of the sine of x. Okay, with this function, because there's a multiplication, x cubed multiplied by the tangent of the sine of x, you probably guessed correctly that we're going to be using the product rule, which we have to use the product rule when you're multiplying two functions together. But in addition to the product rule, we also have to use the chain rule. So we know that we're using the chain rule because we use the chain rule when we compose one function with another. So, like for example, we're putting the sine function inside of the tangent function. So and then also x cubed is the power, so we'll have to use the power rule. So we'll be using the power rule, the product rule, and the chain rule in this example. And the order in which we use these rules is going to matter. So we're going to start off with the product rule first, and because the product is what stands out to us the most. In fact, if we call this function f and then this function over here g, then the product rule says we take the derivative of f, multiply it by g, and then add to that f times the derivative of g. Okay. Now, out of these four things, f prime, g, f, and g prime, the derivative of f is 3x squared by the power rule. G we just copy and paste. F we copy and paste. And then g prime, this part right here, is where we're going to have to use the chain rule. Okay. And then f prime is where we use the power rule. The functions f and g, since they don't have prime symbols, we can just copy and paste them as we go along here. So let's go ahead and see how this will work. Let's do f prime over here on the side first. F prime using the power rule will be 3x squared. And then g prime, since that's a composition of functions, we'll use the chain rule, so we have to take the derivative of the tangent function, which would be secant squared. And then what are we taking the secant squared of? It's the same thing that we're taking the tangent of, namely the sine of x. And then the chain rule says we multiply by the derivative of the inside. Derivative sine is cosine. So there's g prime. Then if we just kind of take these and put them together according to the product rule formula, we get y prime is equal to f prime, which is 3x squared, times g. This is where I copy and paste the tangent of the sine of x, plus f, which is x cubed, and then multiply it by g prime of x. And g prime of x is cosine of x times secant squared of the sine of x. I just rearranged the factor and put the cosine out in front. And there's really no simplification that we can do here. So we're done. This is the derivative. Okay, so on to example 2. And example 2 will be, we're going to differentiate the function y is equal to x squared plus x times the sine of x all to the 4th power. Okay, we're going to use the power rule here again because of the x squared term in the middle. We're going to actually use the power rule twice because we have a x squared, but then we have this whole parentheses raised to the 4th power. So we're going to have to use the power rule twice, one of which we're going to have to use the chain rule on. Because with the chain rule, once we take that 4th power and put it out in front, and then subtract 1 to get a 3 for the new exponent, we're going to have to multiply by the derivative of the inside, which we'll get to in a minute. And then the inside is being x squared plus x times the sine of x. And then if you look at one term in the middle, x times the sine of x, because of the multiplication, we're going to have to use the product rule. So here, instead of using, if you compare what we were doing with example 1, we started off with the product rule first, and then we realized that in the process of doing the product rule, we had to use the chain rule. Here, we're going to start off with the chain rule, and then we're first, and then we'll use the product rule later, or second. So that's why I was saying the order in which you use the different rules of finding derivatives will matter. So here we will start off with the chain rule and the power rule. So the power rule says bring the 4, put it out in front, and then we can just copy the inside of the parentheses. So 4 minus 1 is 3. That's what the power rule states. And then because we just took the derivative of the outside function, we still have to multiply by the derivative of the inside function. So here we're going to have to put a big prime symbol right there. So here we're going to have to take the derivative of x squared plus x times the sine of x. So this multiplication is because of the chain rule. And then when we get in a moment to take the derivative of the inside function, we can see x times the sine of x. That multiplication says that we have to use the product rule. Okay, so let's focus on taking the derivative of this second part right here. Okay, so we're going to copy this down here. Okay, so now the derivative of x squared is 2x. We're using the power rule the second time here. And then we have to use the product rule on x times the sine of x. So I'm going to go a little to the side here a little bit in the margin and write down x times the sine of x and put a prime symbol there to see what the derivative of this is going to be. And the derivative of this will be, we have to use the product rule. So we take the derivative of x, which is 1, times the sine of x plus x times the derivative of sine, which is cosine of x. So that boils down to just the sine of x plus x cosine of x. So it's this right here that we're going to put, and over here next to the finish off where we left off and put plus the sine of x plus x cosine of x, and then you end the parentheses, and then that turns out to be the derivative of the second example. So we did use the product rule, but we used it in the margin, and then we used as our main rule the chain rule. Whereas in example 1 that was reversed. We used as our main rule the product rule, and then used the chain rule as a little aside rule that we put in the margin. Okay, so now we're going to do a third example. And this example will be y equals x cubed times the tangent of the sine of x, all divided by x squared plus 1. So for this, we're going to be using the power rule, the chain rule, the product rule, and the quotient rule because of the division by x squared plus 1. But fortunately for us, if you look at the numerator, the x cubed times the tangent of the sine of x, you'll notice that that is the same function that we found the derivative of in example 1. So all we have to do is basically cut and paste the answer to number 1 that you see right here where the star is. That's our answer. And we're going to basically cut and paste that answer when we take the derivative of example 3. So because of the quotient involved in example 3, or the division, we're going to have to use the quotient rule. Leave myself enough space. We write y prime. And so let's just write down what the quotient rule says. Okay, so we're going to break up the numerator and the denominator together. We'll call this the numerator f, and the denominator we'll call g. So if we write down the quotient rule, okay, quotient rule says g times f prime minus f times g prime, and then the whole thing divided by g squared. Okay. F and g, we already know what they are, so we can copy and paste. We already know what f prime is too. F prime, where I'm pointing the arrow to, that comes from example 1. And then G prime is really easy because you just use the power rule. And then everything else we can just kind of cut and paste. So with this, G, we're going to start off with G, which is x squared plus 1, and then put a little check mark next to G. And then we have to take G and multiply it by f prime, and f prime we found in example 1, so I'm just going to copy and paste what I have in example 1. See if I copied that down right. Okay, looks good. And then I subtract from that f, which is the numerator, so what we're trying to take the derivative of. So I just copy and paste the numerator, x cubed times the tangent of the sine of x. And then now, so we put check marks next to these three. Now we have to do G prime, which is the power rule. So that's pretty easy because the derivative of x squared plus 1 is simply 2x. And then that 2x gives us that. So putting this right here, this would be G. All of this right here is going to be f prime. And this part here is f, and then this little part here is G prime. Okay, so we multiply those two together and subtract. And then now all we have to do is divide the whole thing by G squared. So take x squared plus 1 and square it, and then this little part is G squared. Okay, so we're done. Now taking the derivative. We won't bother simplifying this. We'll just leave it as is. Our goal is just to learn how to use the combined derivative rules. So hopefully these three examples have kind of showed you how to go about thinking, how to use these derivative rules, and which order to use them. And a lot of what we do is just mental bookkeeping. You have to, just like in algebra, you have to learn the rules and then learn how to use them appropriately, and the same thing is true when you're using the rules of derivative rules of calculus. So hopefully this helps, and that's the end of this topic, and we wish you good luck in your studies. Take care, and bye-bye.